Hello. In the prior section, we introduced the very first type of way that we can graph quadratic equations or quadratic functions, and that's by making a table. While that will always work, it can be fairly tedious and cumbersome, and there's much more efficient ways that we're going to look at today. And also, we only looked at situations when we were looking at what happens when the value out front, the a value you alter, that makes the graph steeper or wider. What happens when you change c, it moves it up and down. Now we're going to look at a more general type of quadratic. What if it has all terms, x squared and then plus bx plus c? So how do I graph ones like that? We're going to get to that, but to start, I'm going to ask you kind of a review question from the last section, just describing in words how would the following three graphs compare to the parent function? The parent function y equals x squared is graphed already right here. How would these graphs compare to the parent function? Your word bank are words like it moves up this much, it moves down this much, it is steeper, it is wider, it is upside down. So pause the video now just to do a little refresher of how the last lesson went, see how it went before we move on to more general types of quadratic functions today. So pause the video now, give it a go. Okay, here we go. First one, we should see this plus 4. This is what you should have said. You should have said it moves the graph up 4. I think this program, yeah, it will graph it for me. If I graph it, look, it did. It moved it up 4. The next one, what happens if I multiply by a number out front? Oh, this isn't going to graph it for me. That's too bad. I wonder if I undo this. Can I only graph 2 at a time? Yep. Okay, so I'll do the next one. It's going to make it steeper, right? Because I'm multiplying by a number bigger than 1. So what you should have written for this one is steeper. It makes the graph steeper. Get this one off of there and do the last part. What if I put a negative out front? That one's going to make it graph and open upside down. So it's the exact same graph, just opening upside down. What you should have written is it'll make the graph be upside down. So there we go. That's a good way to check just your basic understanding of how quadratic functions change based on multiplying by a number out front or adding or subtracting by a number at the end, adjusting what we call the a or c value. We're going to look at a more general way to graph quadratics today, though. So here we go to start. We're going to graph more general ones, equations of the form y equals x squared plus bx plus c. We're going to leave a to be 1 for the rest of this chapter, and we'll look at situations in the next chapter where a will not be 1, but for the rest of the ones that we look at, a will be 1. If I look at, here's some graphs of some parabolas, I want to point out a very important feature about these graphs. So the first question I'm going to ask you is what's true about the y-coordinates of the x-intercepts? Well, let's just start by circling the x-intercepts. The x-intercepts are where these graphs cross the x-axis. Recall the x-axis is this axis. It's the one that runs left and right because your x is your left and right coordinate. The up and down is your y-axis. I'm circling where these graphs cross the x-axis. We call those the x-intercepts of the graph. If you look at them, they all have one thing in common. Their y-coordinates are all the same. All of the y-coordinates are equal to 0. Y is equal to 0 for x-intercepts. The reason why is because you're on the x-axis. You're not above it, you're not below it, you are on it, so your y-coordinate has to be 0. That's very important. The next feature I'd like to point out, is what do you notice about the vertex in relation to where those x-intercepts are located? Well, the vertex is actually right in the middle of it. It's an equal distance to the left and right. So the vertex is halfway between the two x-intercepts. If you know where the x-intercepts are, you can easily get to the vertex because the vertex is right in between. It's right in the middle. So where's the vertex located in relation to those blue x-intercepts? The vertex is right in the middle. It's halfway between them. And that's going to be the key for us graphing the quadratic equations and functions that we look at. We're going to first find the x-intercepts. And if we know where the x-intercepts are, we can get where the vertex is because the vertex is going to be halfway between them. So that's going to be our goal. Our goal is in order to graph these quadratic functions, we need to first find the x values that make y be 0. We have a name for those. Those are called the roots, the zeros, or the x-intercepts. Those are 3 different names for the same thing. In English, they call those synonyms. So those are all synonyms. They're different words for the same thing. We will use those mostly interchangeably. So they're the values for x that make the y value be 0, which is going to be where the x-intercepts occur. They're called the roots because they're the root of our graph. They're the very first things that we find. They're also called zeros because they're the x values that make y be 0. They're also called x-intercepts because if your y-coordinate is 0, you are on the x-axis, you are intercepting the x-axis. So they all have very important properties, but they all imply the same thing. So here we go. If I want to graph this, the first thing I want to do is find the x-intercepts. We already said the x-intercepts are going to be when y is equal to 0. So 0 is equal to x squared minus 2x minus 8. I want to solve this equation now, and that's why in prior sections we practiced solving this by factoring. So my first step is to factor the equation so I can solve it. I need two numbers that will multiply to make negative 8 and add up to be negative 2. If it multiplies to be a negative, I know one of them is positive and one of them is negative. And the bigger number needs to be negative because they have to add up to be a negative 2. So you can play, it's either going to be a 1 and an 8 or a 2 and a 4 with opposite signs, and it turns out it's going to be a positive 2 and a negative 4. Those are your factors, but those are not your x-intercepts. Those are just the factors. So step 1 is factor it. Now I can actually solve. What value for x would make this statement be 0? Well, that would be 0 if x equaled negative 2. So negative 2 is my first 0 or root or x-intercept. They all mean the same thing. My other one, well, what would make this be 0 if x equaled 4? So there is where my two x-intercepts for my graph are going to be located. If I put either of those values back into the original equation, if I either put 4 in for x or negative 2 in for x, I'll get 0 for y. Let's just do a quick check to show. Put 4 in for x. 4 squared is 16. So I'd have 16 minus 2 times 4 is 8, minus 8. 16 minus 8 will make 0 for y. So it works. There's my two x-intercepts. Now I'm going to go back to the picture that we showed. If I know where the x-intercepts are, I actually know the vertex is location because it's halfway between. Halfway between negative 2 and 4 is going to be where? Well, you can kind of eyeball it with the graph, but if you are struggling eyeballing it, you can use an equation. It turns out that halfway between two numbers is just the average. It's the balancing point. The balancing point is the average. So imagine you had two test scores. How do you find the average score? You add them together and divide by 2. So if I want to find the vertex's x-coordinate, I'm going to use a v to stand for vertex. I'm going to use a little x to stand for its x-coordinate. Its x-coordinate is going to be the average of these two x-intercepts. So negative 2 plus 4, and then divide by 2. Negative 2 plus 4 is 2, and 2 divided by 2 is 1. I actually see that halfway between those two x-intercepts is going to be when x is 1. That's what we call the axis of symmetry. The axis of symmetry of this graph would be x equals 1. But what I don't know is I don't know currently how high or how low the vertex is going to be on this graph. I should know because the a value out front is positive that it has to open up. So it's not going to be up here because that would make the graph open down. It's going to be down here, but I don't know how far down. All I know right now is that the vertex has an x-coordinate of 1. If I know the x-coordinate, how do I get a y-coordinate? You use the equation. That's what an equation is. It's the mathematical relationship between the coordinates. If I know x is 1, if I put 1 in for x, I'll be able to get the y-coordinate. So the vertex is y-coordinate, v standing for vertex. I'm going to put a little y in the subscript so I know I'm finding the y-coordinate of the vertex. I just need to put 1 in for x. 1 squared minus 2 times 1 minus 8. And then simplify. 1 squared is 1. 2 times 1 is 2, so 1 minus 2 minus 8. 1 minus 2 is negative 1, minus 8 is negative 9. So I actually know that my vertex is located at negative 1, negative 9. It'll be right there. Again, this dashed blue line is just a guide. It's where your axis of symmetry is. It's not actually a part of the graph. It's just an imaginary line. So I've got the two x-intercepts. I've got the vertex. There's actually one other point I get for free, and it's the y-intercept. The y-intercept, well, think about this. If your x-intercepts are where y is 0, your y-intercept is on your y-axis. That's when x is 0. So if I go to my equation, y equals x squared minus 2x minus 8. If I want to find the y-intercept, I just put 0 in for x. If I put 0 in for x, I'm going to get 0 minus 8. It's just going to be -8. So my y-intercept is the point 0, -8. And it actually turns out that your y-intercept will always be this last number. It will always be the c. c is your y-intercept. So my y-intercept is right there at -8. And now I have the left side of this graph. I know the left side looks like that. The right side is just a mirror image. So it looks like that. And there is my full-on picture. I used my two x-intercepts to get started. I found halfway in between, which is the vertex. And then I found the y-intercept in its reflection, and I sketched the point. When you do this process, you're going to get 5 points. You're going to get the two x-intercepts, you'll get the vertex, you'll get the y-intercept in its reflection. You're going to get 5 points. Let's try another, and then I think I'll have you try one. So first thing I want to do is I need to find where the x-intercepts are. So this is just like a little puzzle that has a very set number of steps that you go through. It's a very kind of concrete process, but they all interconnect. So it's a good logical thought process. Factor the equation to start. I do that because I want to know when is y going to be 0. So I need to solve this equation. If there's no number out front, it's really because it's a 1 if there's still a variable left. Now I factor it. What two numbers multiply to make -6 add up to be -1. Again, if they multiply to make a negative and add up to be a negative, they have to be opposite in sign, and the bigger number needs to be negative. This one's going to be +2 and -3. I can check because 2 times -3 is -6, and 2 plus -3 is -1. So there's my factors. Once I have the factors, I can get the zeros or the x-intercept. This one will be -2. This one will be 3. So -2 and 3 are going to be your x-intercepts. Now the vertex is halfway in between. How do I find halfway in between? I average. So the vertex's x-coordinate is the average of the x-intercepts. When I add the tops together, I get 1, and 1 divided by 2 is a half. So my vertex's x-coordinate is 0.5. 1 is right here, so I'm actually like right about there. That is where my axis of symmetry is. My axis of symmetry is x equals 0.5. That's where the middle fold line is going to be for my parabola. If I know the x-coordinate, how do I get the y-coordinate? I put 0.5 for x into the equation for x. So my vertex's y-coordinate will be 0.5 squared minus 0.5 minus 6. If you've got a calculator handy, you can actually type that in as you see it. 0.5 squared, subtract 0.5, and then it was minus 6. So subtract 6. I get -6 1/4. Decimals are numbers too. So -6.25. I actually need a little bit more room there. -6.25. And I plot that. 0.5, -6 1/4. It's right there. And then my last is my y-intercept. My y-intercept is where the graph is going to cross the y-axis. That is when x is 0. If I put 0 in for x in my equation, this will disappear and this will disappear. I'm just going to end up getting y equals 0 minus 0 minus 6. Well, that would be -6. So my y-intercept will be -6. Now I have the left side of the graph, and then the right side of the graph is just the mirror image. And voila, I've graphed the equation. There you go. There's two good examples that you can use as a template. I'm going to ask you to try it for yourself, little self-check-in. You try it with this one. So pause the video now for as much time as you need until you've tried it all the way through, or you feel like you've gone as far as you can until you've gotten stuck, and then unpause it once you want to see it all the way worked through. Okay, I'm going to go through this one pretty quick since it's a you're trying on your own, a yo-yo, a you're on your own. Factor it first, because I want to know when is y going to be 0. So what numbers multiply to be 8, add up to be -6. If they multiply to be a positive and they add up to be a negative, I know that the factors both have to be minuses, so -2 and -4. The order in which you write those doesn't matter. Your zeros then are going to be 2 and 4. So you plot those. 2 and 4 are your x-intercepts. The vertex has to be halfway between. You might be tempted to use the formula for it to add them together and divide by 2, but you should just be able to look and see halfway between 2 and 4 is 3. If you use the formula of averaging, 2 plus 4 is 6 divided by 2, you're going to get 3. So there's where your axis of symmetry is. That's where your vertex's x-coordinate is going to be located. It's going to be somewhere on the line, x equals 3. Now we need to find how high or how low it's going to be. If I know the vertex's x-coordinate is 3, how do I get the y-coordinate? I put 3 in for x in the equation. So the vertex's y-coordinate has to be 3 squared minus 6 times 3, and then plus 8. That will be 9 minus 18 plus 8. 9 minus 18 is negative 9 plus 8 is going to be negative 1. So my vertex's y-coordinate is negative 1, so my vertex is right there. And then my last point is my y-intercept. I look at the number at the end. It's an 8, so my y-intercept is the point 0, 8. Plot it and graph the left side. Mirror image this over there. And I have the right side. There's all, ooh, kind of missed that a little bit. And there's my 5 points. I have my 2 x-intercepts, my vertex, my y-intercept, and its reflection. And that's what it should have looked like when you did it for yourself. Last one that we're going to try is a special case, and then that'll be it. This one's a special case because you'll see it doesn't look like the ones we had before. It's not x squared plus bx plus c. It's actually ax squared plus bx. The reason why this is a special case one is because the type of factoring you have to do is different. It's actually greatest common factor factoring. It's the very first type of factoring that we learned how to do in a prior section. So if you need to, you might need to go back and review the lesson on special products and greatest common factor factoring. We still want to know when is y going to be 0. That doesn't change. It's just how we're going to factor is going to change. When I factor this, there's no c to kind of multiply by. So what I'm going to do instead is I'm going to think to myself, okay, I need to divide out the greatest common factor. What's the biggest number I can divide out of negative 2 and 4? Well, it's a negative 2. And then what's the most amount of x's I can divide out? This has 2 x's, this has 1. I can divide 1 x out. And then in parentheses, I need to write what's left behind. I'm doing the distributive property backwards. This was a negative 2 and I divided a negative 2 out, so technically there's a 1 right here. This had 2 x's and I divided 1 x out, so there's 1 x left behind. This was a 4 and I divided a negative 2 out, so there has to be a negative 2 here, because if I multiplied back through, negative 2 times negative 2 would make the 4. This only had 1 x, so there's no x's left, so this now is factored. Now I'm going to use it to solve. What value for x would make this be 0? Well, if x equaled 2, what about this? Negative 2 times what will make 0? A lot of people think it's positive 2, but negative 2 times positive 2 will not make 0. This will actually be x equals 0. Negative 2 times 0 makes 0. So there's my 2 x-intercepts. Where's the vertex? Halfway between. You shouldn't need to use the formula for this one. You should be able to know that halfway between 0 and 2 is going to be 1. But if you use the formula, it obviously needs to work. So 0 plus 2 makes 2. 2 divided by 2 is 1. So my vertex is x-coordinate is going to be 1. That's where my axis of symmetry is. That's going to be the middle of my graph. If I know the x-coordinate for the vertex, how do I get the y-coordinate? Well, I put 1 into my equation for x. So it would be negative 2 times 1 squared plus 4 times 1. 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4. Negative 2 plus 4 makes 2. So now I know that my vertex, its entire point is 1, 2. Located right there. The last point is my y-intercept. If I look, my y-intercept is always the number at the end. There is no number at the end. It's a 0. So actually my y-intercept is 0, 0. Turns out in this case, my y-intercept turns out to also be an x-intercept. So if you have ones like this where you have to do greatest common factor factoring, turns out you're only ever going to get 3 points because the y-intercept is an x-intercept. So all I know is the graph looks like that because the y-intercept is the origin and its reflection is the other x-intercept. So if you have to do a greatest common factor factoring one, because there's only 2 terms, you're only going to get 3 points for this technique. But still a good way of graphing. And that's it. Thank you very much. Have a good day.